Hello. In continuation with our video lectures on friction, today's lecture we would focus on those numericals where impending motion is not clearly mentioned. Many a times students get confused and they try to remember and mug up that friction force is equal to mu s into m. We have to be very careful in statics, especially in friction, where if you know that the block is impending, then and only then is the friction force maximum, and only at that maximum point can we write friction force equal to mu s into m. At all other cases, if the block is stationary but not impending, then friction force is less than maximum, where it is not equal to the magnitude of mu s into m. So it is very necessary in the chapter of friction while solving a problem to be dead sure that we are having a condition of impending motion. Now, sometimes they may ask us to find out whether the block is moving or stationary. When I say moving from the statics point of view, it means it is on the verge of moving and it is impending. So let us consider a very small example to clarify this concept. These are very small numericals involved. In the first case, suppose we consider a simple block placed on the ground which is horizontal. 200 Newton is the weight of the block suggested. The coefficient of static friction between the block and the ground has been given as 0.4, and find the force of friction if a horizontal force of 40 Newton is applied as shown in the right. So let's understand the problem what it is. The weight of the block has been given clearly. The surface, if you note, is not inclined. It is purely horizontal. The coefficient of static friction between the material of the block and the ground is 0.4. And in addition to that, even the external force applied of 40 Newton has been given. Now, whenever the question asked is about finding the force of friction, we have to be very careful. So today's video lectures, we will focus on only those questions where the condition of the block will not be given clearly. So they have not mentioned in the problem that when the force P of 40 Newton is applied, what is the condition of the block? There can be three cases. Force P of 40 Newton may be so large that this block is physically moving and it goes into dynamics, or force P and everything has been adjusted such that this block is just about to move, which is impending case, but you do not know before you solve this. And third, maybe your friction is too large and the 40 Newton force is not enough even for this block to go into impending. So in the third case, when you apply the force 40 Newton, the block will remain there and stationary, but not even go into impending. So in problems where force of friction is to be found out, we have to make an assumption. First assumption is to be made about the nature of impending motion, because only during impending we can write friction force equal to mu s into n. That is the first assumption. And for that assumption to be made, one of the given known quantities should be assumed to be unknown. Now initially some students find this a bit confusing to understand. So let me give you an example. In this case, what happens to the block when we apply a force of 40 Newton is not known. So, in order to clarify it, let us assume that force P be unknown. Let us assume altogether different force P whose magnitude is not known for impending motion. Of the block towards the right. Because we on our own have assumed impending, therefore Without thinking, we can draw the friction force opposite to that of this sense. Without saying, we can say that the friction force is maximum. And a maximum friction force is obviously equal to mu s into n, where mu s has been given. So let me draw the free body diagram of this condition. In this condition, like always, the first force which we logically draw must be the self-weight. A 200 Newton force of self-weight has been acting down. Now think of the third law. Because weight is acting down, therefore the ground will give a normal reaction of the ground on the block. This normal reaction would look like upwards. I call it normal reaction of the ground, and I write a question mark in front of it because its magnitude is not known. So weight acting down, normal reaction acting upwards, and external force P acting towards the right, not 40, but remember this force P, whose magnitude we want to find such that this block undergoes impending motion. If it is impending motion, now one can clearly say that friction force will always be opposite to this. Friction force will be maximum, and maximum friction force can be written to be equal to mu s multiplied by the normal reaction. So in this case, 0.4 multiplied by normal reaction of the ground. So we are solving the problem not for this value of P, which is 40. We are solving the problem for our case of impending motion. If you notice clearly, this becomes a concurrent force system. How many unknowns can we have? In this case is obviously 2 and not more. Why can we have only 2 unknowns? Because we have only 2 equations of sigma fx is 0 and sigma fy is 0. If you notice this very carefully, so that we can save time, writing summation of forces in the y direction is 0 invariably will give me one answer directly. So normal reaction of the ground and P are the 2 unknowns. If I write sigma fy is 0, normal reaction is plus, 200 being downwards is minus, normal reaction of the ground minus 200 is 0, and therefore normal reaction of the ground would turn out to be 200 Newton. Now, by the time you write your exam, taking a look at this and writing normal reaction of the ground would become very obvious. But for the exam sake of you, so that you get some marks for the steps, it is advisable to write sigma fy is 0. Usme zyada time nahi jata hai. You can say that there are only 2 people. Upward is plus, downward is minus. You don't need a calculator. Normal reaction is equal to the weight acting down. This is one half of the story. Now, summation of forces in the x direction is also 0, because remember we are talking about impending case. The impending case is the last point of statics, beyond which dynamics. We are still on the boundary of statics. We are still in equilibrium. Hence, sigma fy is 0 and sigma fy is 0 can be used. Now, in case of sigma fx is 0, P going to the right, we will call it as positive. Friction force going to the left and opposing the motion of impending, hence it is negative. So, plus P minus 0.4 Ng would give you 0. Now, as we have seen in the previous lectures of friction, normal reaction must always be eliminated in all the problems of friction. So, normal reaction Ng found in the sigma fy equation, we will actually substitute it here in the sigma fx equation. P minus 0.4 times 200 would give you 0. Now, P in this case would turn out to be 80 Newton. Now is the time to understand this concept. Remember that we have assumed impending motion. So, other way around, if I ask you, what happens to this block when we apply a force of 80 Newton is that the block goes into impending motion. Now we are dead sure as to what happens to this block at this force. Let's compare. What if I apply a force more than 80, which is more than impending? Definitely you can visualize that being more than 80, the block will physically start moving to the right and go into dynamics. But we are not solving dynamics. So third case, what happens if I apply a force which is less than 80? In that case, will the block impend? No. Will it remain stationary? Yes. But now if you notice, how much less than 80 has no answer, which means what will happen if I apply a force 79 Newton at this place? At 79 Newton, this block will continue to remain stationary. It will not be in the impending motion. Impending के लिए उसको 80 चाहिए. If I apply 79, this block will remain stationary. Now, what will happen if I apply 75 Newton? Is 75 less than 80? Yes, block will remain stationary. What will happen if I apply any other value less than 80? Then your block will remain stationary. Not impending but stationary. So now we will say, since P actual, if you remember in the actual case they have asked us to find out what happens at 40. So how much is P actual in this case is 40. So we will make a statement, since actual force P is less than P required for impending motion, therefore at 40 Newtons, now we know that 40 is less than 80, therefore at 40 Newton the block remains stationary. The block remains stationary. And if it is stationary, remember we still have equilibrium. We can now draw the free body diagram of the same block again with the value of P as 40. Because we know what happens at 40, it remains stationary. So, the first and the most obvious force would be the 200 Newton acting downwards. Normal reaction of the ground acting on the block would be acting upwards. External force of P, which is 40 Newton, would be acting to the right. And opposing this, there would be a force of friction which will be acting to the left. But remember, we are talking about a block which is stationary. If it is stationary, it is not impending. Friction force is not maximum. Friction force could be less than maximum, and how much less उसको limit नहीं है. But stationary का मतलब है summation of forces in the x direction would still be 0. We could get minus the force of friction plus P is 0. Force of friction is equal to P. And force of friction will become equal to 40 Newton, which is obvious because we are talking about equilibrium. Thank you.